All right, in this section, we're going to begin chapter 4 dealing with number theory. And in this chapter, we're going to be talking about topics like divisibility. We're also going to talk about prime and composite numbers, and also we'll talk about greatest common divisor and least common multiple. Those are the highlights of chapter 4. Now, the first section of chapter 4 deals with divisibility. And in this section, we're going to define divisibility, factors, and multiples. Also, we'll perform the divisibility test for 2, 3, 4, 5, 6, 8, 9, 10, and 11. Then we'll recognize that the set of factors is finite and the set of multiples is infinite for any given natural number. Okay. Now let's talk about or define divisibility. We'll talk about divisibility, but we need to also define it as well. An integer is even if it has a remainder of 0 when divided by 2. Otherwise, it is odd. Okay? An integer is even if it has a remainder of 0 when divided by 2. Otherwise, that integer is going to be odd. Now, let's say here we have this. When we say 3 divides 18, we can write it like this, the 3 with the vertical bar and then 18. 3 divides 18. And that's because the remainder is 0 when 18 is divided by 3. And likewise, b divides a can be written like this, the b with the vertical bar and then a, meaning b divides a. And that means that the first number can go into the second number an even number of times with a 0 remainder. Now we say that 3 does not divide 25 as written like this. 3 with the vertical bar, but there is a slash over that vertical bar. And then 25. And that's because the remainder will not be 0 when we take 25 and divide that by 3. In fact, you'll get 8 with a remainder of 1. Okay. All right, now let's look at some definitions here. Like in this case, for any whole numbers A, and B, where B is not 0, B divides A if and only if there is a unique whole number called Q, such that A is equal to B times Q. Okay. Now, if B divides A, then that means that B is going to be a factor or divisor of A, and A will be a multiple of B. Okay. Now let's look at this first example that deals with divides. Classify each of the following as true or false. Like in part A, 3 divides 12. Well, that would be true because if I divide 3 into 12, that will go evenly 4 times with a 0 remainder. So this would be true. Part B, 0 divides 2. Well, what that's saying is this, 2 divided by 0, that's what that's actually saying. And there is no number where 0 times what number would give us 2. So in other words, this will be false. Because 0 divides 2 means 2 divided by 0. And as we learned before, division by 0 is undefined, so that has to be false. Now part C, 0 is even. Well, actually, this will be true. Because if I take 0, divide that by 2, I will get 0 with a 0 remainder. Part D, 8 does not divide 2. And that symbol means does not divide. So 8 does not divide 2. And that would be true because there is no whole number where 8 times whatever that is would be 2. Now part E, for all whole numbers, A, 1 divides A. And in this case, this is going to be true as well, because 1 goes into every whole number. And part F, for all non-zero whole numbers, a squared divides a to the 5th. So in other words, if I do a to the 5th divided by a squared, I can come up with something like a to the 3rd. Okay, so that would be true. Next, 3 divides 6n for all integers n. That's also true, because I know 3 can go into 6 2 times, or any multiple of 6. Now, part H is 3 does not divide 5 times 7 times 9 times 11 plus 1. Let's write this as 3 does not divide, and I need to simplify 5 times 7 times 9 times 11 plus 1. And you're going to get 3,466. And I'm going to have to cheat a little bit with this calculator, because if I do 3,466 divided by 3, here I'm going to get a decimal. I'm not going to get a whole number from that. So in this case here, 3 does not divide 3,466 would be true. And the last one, 0 divides 0. That's just saying 0 divided by 0 in this case. That too was undefined. So this is going to be false. And that was from the section 3.5 that we talked about that dealt with a division of whole numbers. So this is like saying 0 divided by 0. That's undefined. So that's why that answer is false. Okay. All right, next we'll look at some properties of division. And that's for any whole numbers, A and D. If D divides A and N is going to be any whole number, then D will divide N times A. So I can take N, multiply that by whatever A is, and guess what? D will divide some multiple of A. So in other words, if D is a factor of A, then D is a factor of any multiple of A. Okay. And here are some more properties of division. And we'll go through each one of those individually. For any integers A, B, and D, where D is not equal to 0, here, if D divides A and D divides B, then D will divide the sum of A and B. So let's say 2 divides 8, which is true, and 2 divides, let's say 12. That's going to be true. Then what that means here, what means is this: 2 will divide the sum of 8 and 12. And if you add 8 and 12 together, you will get 20. And 2 does divide 20. So that's what that first property states, part A. Now part B, if D divides A and D does not divide B, then of course D will not divide the sum of A and B. So let's say 2 divides 8, which is true, and 2 divides, let's say 13, which we know that's going to be false. So that means 2 will not divide 8 and 13, because one of them, the 2 did not divide the other number. because one of those numbers is not divisible by 2 in this case. And 8 and 13 will give you 21. So 2 would not divide 21. All right, part C is if D divides A, D divides B, and A is greater than B, then that means that D will divide the difference of A and B. So let's say here, 3 divides, say 6. No, take that back, because A has to be greater than B. So 3 divides, let's say 27. And of course, 3 divides 6. Well, here, this number 27 is greater than 6. So that means here, if I do 3 divides, the difference of those two, or 27 minus 6 will be 21. And 3 does divide 21. So that's what that property is stating. Now, part D, if D divides A and D does not divide B, and A is greater than B, then that means that D will not divide A minus B. So 3 divides 27. And let's say 3 does not divide 5, which is, of course, true. So if I wrote this, here 27 minus 5 would give you 22. That's not divisible by 3. So 3 would not divide the difference of 27 and 5. And then part E, D does not divide A and D divides B, but A is greater than B, then for the same reason, D will not divide A minus B. Okay. Because I can say here 3 divides 28, which is false. So 3 does not divide 28. And 3 divides 6. So this is also true here. Because 28 minus 6 will be 22. 22 is not divisible by 3. Okay. All right. Let's look at some examples of this. Classify each of the following as true or false, where X, Y, and Z are whole numbers. All right, part A, if 3 divides X and 3 divides Y, then 3 divides the product of X and Y. This will be true. So 3 divides 27 and 3 divides 6. So 3 divides 27 times 6, and whatever 27 times 6 is, that's going to be divisible by 3. So let me do this. 27 times 6 would be 162. So 3 divides 162 evenly. Part B, if 3 divides the sum of X and Y, then 3 divides X and 3 divides Y. That's going to be false. An example of that would be, let's say 3 divides, of course, 18. Let's say 3 divides 18 plus 5. That means 3 divides 18, which is, of course, true, and 3 divides 5. But this part right here, that 3 divides 5, is false. So that means this statement here in part B is going to be false. Part C, if 9 does not divide A, then 3 does not divide A. Let's look at an example of that. Well, 9 does not divide a bit. Let's say 6. And we know that, or better yet, I'm going to try this number. Let's try 21. We know 9 does not divide 21. 3 does not divide 21. That's false because 3 does divide 21. So in this case, this one would be false. Right? All right, now let's take a look at this first homework example here, where it says here 6 is a multiple of 48. 6 is a multiple of 48. So what that's really trying to tell you is 48 divides 6. 48 divides 6. Can 48 go into 6 evenly? That answer would be no. So that means that this statement 6 is a multiple of 48 is going to be false. Okay. All right, now let's look at some of our divisibility rules here. Sometimes it is useful to know if one number is divisible by another just by looking at it. Like, for example, to check the divisibility of 1734 by 17, we note that 1734 is going to be 1700 plus 34. We know that 17 divides 1700 because 17 divides 17. And 17 divides any multiple of 17. Furthermore, 17 divides 34 because, well, 17 goes into 34 evenly with a 0 remainder. Therefore, we can conclude that 17 divides 1734. And another method to check for divisibility is to use the integer division button or the INT division on a calculator. All right, so in this case, I do have a calculator. Might be hard for you all to see, but this calculator, the TI-34 multi-view, does have a button that says INT division. I know that's going to be hard to see, but right above that division key, there is INT divide. And to get to that, you have to press the second key and division. So for 1734, I'll type that in. And to get the integer division, we press the second key and then division. It'll give you INT with division. And then enter 17 and then press enter. Here's what it's going to give you. It's going to give you the quotient and the remainder. So here, this is 102 with the remainder of 0. Okay, so here, 1734 is divisible by 17. Okay. But for now, I want to deter you from using the calculator to determine whether numbers are divisible by another number. I want you to look at them by sight and use these rules here that I'm about to give to you. Like for 2, 5, and 10. We'll start with that one. 2, 5, and 10. A whole number is divisible by 2 if and only if its unit digits is divisible by 2. That means the last digit in the whole number must either end in 0, 2, 4, 6, or 8. Okay, that's the last digit, which is the units digit. It's either going to be either 2, 4, 6, or 8 for that number to be divisible by 2. All right, next is a whole number is divisible by 5 if and only if its units digit is divisible by 5. That is, if and only if the units digit or the ones digit ends with a 0 or a 5. And then a whole number is divisible by 10 if and only if its units digit is divisible by 10. That is, if and only if the units digit is 0. Must end in 0 in order for that number to be divisible by 10. Okay, so now let's look at this homework example. Is the first number divisible by the second number? Okay, so is 244,282 divisible by 5? Well, let's look at the rule for divisibility by 5. If the last digit must end in a 0 or a 5, in 244,282, does that number end in 5 or 0? And the answer for that would be no. 244,282 would not be divisible by 5. Right. Now, let's talk about the divisibility test for 4 and 8. 4 and 8. A whole number is divisible by 4 if and only if the last two digits of the number represents a number divisible by 4. And a whole number is divisible by 8 if and only if the last three digits of that whole number represents a number that is divisible by 8. Okay, so for divisibility by 4, let's say 1,728. Well, this is divisible by 4 because if you look at the last two digits, 2 and 8, 28, that is divisible by 4. So 1,728 would be divisible by 4. And then for 8, I'm trying to think of one, let's see. Let's say 15,224. If you look at the last three digits, 224, divide that by 8, it is divisible by 8 evenly. The 2, 2, and the 4, that is divisible by 8. So 15,224 is divisible by 8. Now let's look at a couple of examples here. Determine whether 97,128 is divisible by 2, 4, and 8. Using the divisibility rules, let's look at 97,128. Is it divisible by 2? Well, if you look at the last digit in 97,128, it is an even number. It ends in either a 2, a 4, 6, or an 8, and it ends in 8. So yes, it is divisible by 2. Let's see, what about by 4? So when 97,128 be divisible by 4? Well, take the 28, which is the last two digits, it must be divisible by 4. And in this case, it is divisible by 4. So then 97,128 is divisible by 4. Now, what about by 8? Well, by 8, if we look at the last three digits, the 1, 2, and the 8, if I divide 128 by 8, it would go 16 times. So in this case here, 128 is divisible by 8. So to answer that question, 97,128 is divisible by 2 and by 4 and by 8. Okay. All right, here's another example. Determine whether 83,026 is divisible by 2, 4, and 8. Well, let's start off with by 2. And by looking at this, it ends in either a 0, 2, 4, 6, or 8. It ends in 6 in this case. So that means that this number 83,026 is divisible by 2. What about by 4? Well, the last 2 digits is 26. And 26 is not divisible by 4. So that means 83,026 will not be divisible by 4. What about by 8? Well, the last 3 digits is 026. Well, that's 26. And again, that's not divisible by 8 either. So that's a no there. So this number is only divisible by 2, but not by 4, nor by 8. Okay. All right, here's a homework example. Is the first number divisible by the second number? In this case, is 4 divisible by, well, is 356,051 divisible by 4? Take a look at the last 2 digits. That's 51. And in this case, 51 is not divisible by 4. So that would be a no there. Okay. All right. Now here we have a Venn diagram for the divisibility test of 2, 4, and 8. Okay. And notice that the numbers divisible by 8 is in the innermost circle. So if you have numbers that are divisible by 8, then also you're going to have numbers that will be divisible by 4. And if you have numbers divisible by 4, then that means you're going to have those numbers being divisible by 2. Now, of course, you may have numbers divisible by 2, but not by 4 or not by 8. And then you might have numbers divisible by 4, but not by 8 as well. Okay. All right, next we'll look at the divisibility test for 9 and for 3. A whole number is divisible by 3 if and only if the sum of its digits is divisible by 3. And then for 9, a whole number is divisible by 9 if and only if the sum of the digits of the whole number is divisible by 9. So let's take a look at this example. I want to determine whether 1,002 is divisible by 9. I mean by 3. We'll start with that. Let's see, by 3. Well, if I take the sum of these digits in 1,002, this will be 1 plus 0 plus 0 plus 2. This will give me 3. And 3 is divisible by 3. So 1,002 is divisible by 3. But what about by 9? Well, the sum of the digits have to be divisible by 9. Well, the sum of the digits in 1,002 is 3. 3 is not divisible by 9. So that answer there will be no. Okay, here's another example. Determine whether 14,238 is divisible by 3 and 9. Let's take the sum of the digits in 14,238. So that'll be 1 plus 4 plus 2 plus 3 plus 8. So in this case here, 1 plus 4 will be 5 plus 2 is 7 plus 3 is 10 plus 8 would be 18. Here, 18 is divisible by 3. So that means 14,238 is divisible by 3. And what about by 9? Well, if we took the sum of the digits here, we came up with 18. 18 is divisible by 9. So 14,238 will be divisible by 9. All right, now the next example, the homework example number 4, is the first number divisible by the second number? The first number is that first number divisible by the second number. In other words, is 953,637 divisible by 3? All right, so let's take the sum of that number, 9 plus 5 plus 3 plus 6 plus 3 plus 7. I'm taking the sum of the digits in 953,637. So in this case, if I do 9 plus 5 plus 3 plus 6 plus 3 plus 7, I'll get 33. And 33 is divisible by 3. So that means 953,637 is divisible by 3. Okay. All right, next we'll look at the divisibility test for 11 and for 6. In this case, a whole number is divisible by 11 if and only if the sum of the digits in the places that are even powers of 10 minus the sum of the digits in the places that are odd powers of 10 is divisible by 11. Okay, now that one can be a little bit tricky, but I think I can give you one example of a number that is divisible by 11. Let's try this number, 1,573. And I want to know if that number is divisible by 11 using this divisibility test for 11. So I'm going to add the digits of every number. I'm going to add every other digit, like the 1 and the 7. So here, 1 plus 7 is going to be 8. And then I'm going to add the other digits here, the 5 and the 3. 5 plus 3. That gives me 8 as well. Now, if we subtract 8 minus 8, that gives us 0. And 0 is, of course, divisible by 11. So that means 1,573 will be divisible by 11. Okay. You take the sum of the first and the third, well, the sum of every other digit in that number, and then the sum of the remaining digits, subtract those sums. That difference should be divisible by 11. Okay. Also, an integer is divisible by 6 if and only if the whole number is divisible by both 2 and 3. So we have to know that divisibility rule for 2 and the divisibility rule for 3. For it to be divisible by 6, the whole number must be divisible by both 2 and 3. Okay, here's an example. Now we're going to use all the divisibility rules here that I discussed with you to determine whether 57,729,364,583 is divisible by each of the following: by 2, by 3, by 5, by 6, by 8, by 9, by 10, and by 11. Okay, well, let's start with, is it divisible by 2? The last digit in this number is a 3. 3 is not divisible by 2, so that's going to be a no here. And then what about 3? For it to be divisible by 3, I need to take the sum of all of these digits in 57,729,364,583. All right, so I'm going to do this on the bottom. 5 plus 7 plus 7 plus 2 plus 9 plus 3 plus 6 plus 4 plus 5 plus 8 plus 3. Okay, and I'm going to kind of cheat a bit by using my calculator. Here I'll come up with 59. And 59 is not divisible by 3, so the answer there would be no. Now part C, is that number divisible by 5? Well, the last digit is a 3. For it to be divisible by 5, it must end in a 0 or a 5. Unfortunately, it ends in 3, so that would be no for that. What about divisible by 6? Well, for it to be divisible by 6, it must be, the whole number must be divisible by both 2 and 3. Here, it's not divisible by 2 and it's not divisible by 3. So this answer is also no. What about by 8? Well, if we look at the last 3 digits in this number, which is 583, it must be divisible by 8. And here I'm going to get a decimal for that because I'm going to get a remainder if I try to do 583 divided by 8. So that answer there will be no as well. And then by 9, well, the sum of the digits have to be divisible by 9. Here that sum was 59. 59 is not divisible by 9. So that's no. Now by 10, must end in 0. This ends in 3, so that's going to be no here. And what about by 11? Here I'm going to use this rule up here. And I'm going to go ahead and write out that number, 57,729,364,583. And here I'm going to add every other digit in this number. And that's the 5, the 7, the 9, the 6, the 5, and the 3. 5 plus 7 plus 9 plus 6 plus 5 plus 3. That sum is going to be 12, 21, 27, 32, 35. And then I'm going to add the remaining numbers here, the 7, 2, 3, 4, and 8. Okay, 7 plus 2 is 9, plus 3 is 12, plus 4 is 16, plus 8 is 24. Now I'm going to subtract those two sums, 35 minus 24. That's going to end up being 11. And 11 is divisible by 11. So that means that this large number is divisible by 11. Okay. So now you see how we apply the divisibility test to determine whether one number is divisible by either 2, 3, 5, 6, 8, 9, 10, or 11. And also by 4 as well. Okay. Without using a calculator, test 42,870 for divisibility by 2, 3, 4, 5, 6, 8, 9, 10, and 11. This is similar to one of the homework problems here. Okay. So let's start with by 2. Is it divisible by 2? Well, it ends in 0, so that means it is divisible by 2. But to be divisible by 2 must end in 0, 2, 4, 6, or 8. Okay. What about by 3? Let's take the sum of 4, 2, 8, 7, and 0. 4 plus 2 is 8. 4 plus 2 is 6. 6 plus 8 is 14. 14 plus 7 is 21, plus 0 is 21. Is 21 divisible by 3? Yes, it is. So that means that 42,870 is divisible by 3. Let's see, by 4. The last 2 digits is 70. So if I take 70 and divide by 4, this will go 1 time. Four goes into 30, 7 times. I'm going to get a remainder of 2. So we know it's not divisible by 4. So the answer there will be no. And what about by 5? For it to be divisible by 5, it must end in a 5 or a 0. This does end in 0, so that would be definitely yes. What about by 6? For a number to be divisible by 6, it must be divisible by both 2 and 3. And in this case, it's divisible by 2 and by 3. So that means it must be divisible by 6. So that's a yes there. And by 8. Well, if I take the last 3 digits, 870, divide 8 into that, 8 goes into 8 one time. 8 can't go into 7. Bring the 0 down, 8 goes into 70 8 times. Here I'm going to get a remainder of 6. So that means 42,870 will not be divisible by 8. Let's see, by 9. Now in this case here, I got the sum of the digits here. That's 21. 21 is not divisible by 9. So that means 42,870 is divisible by 9. So this is an example where it's divisible by 3, but not necessarily going to be divisible by 9. How about by 10? Ends in 0, so it is divisible by 10. And finally, by 11. Let's take that 42,870. I'm going to take every other digit and add those together. So that's 4 plus 8 plus 0. That adds up to 12. And then I'm going to add the other 2 digits, 2 plus 7. That would be 9. Now, if I do 12 minus 9, I get 3. And 3 is not divisible by 11. So that means that 42,870 will not be divisible by 11. Okay. So in this case here, 42,870 is only divisible by 2, by 3, by 5, by 6, and by 10. Okay. And here's the last homework example. Using divisibility tests, you want to solve parts A through C below. In part A, can 273 passengers be assigned to 3 flights so that each flight has the same number of passengers? Well, for 273 to be divisible by 3, the sum of the digits in 273 must be divisible by 3. So if I add 2 plus 7 plus 3, well, 2 plus 7 is 9. 9 plus 3 would be 12. Is 12 divisible by 3? And the answer there is yes. So we can assign 273 passengers to 3 flights so that each flight has the same number of passengers. All right, part B. Can a parking lot designed to accommodate 2,027 cars be divided into 11 equal rows? So now we got to use that divisibility test for 11. Add the first and the third number, 2 plus 2. That will be 4. And then add the remaining numbers, 0 plus 7 would be 7. Now, if I do 7 minus 4, that would be 3. Unfortunately, 3 is not divisible by 11. So that means we cannot accommodate 2,027 cars to be divided into 11 equal rows in a parking lot. And part C, can a theater charging $6 per person for admission to a play take in exactly $2,096 for a night's performance? Well, for a number to be divisible by 6, it must be divisible by 2 and by 3. Well, let's take a look at that 2,096. It is divisible by 2 because it ends in 6. Now, what about by 3? Here we need to take the sum of the digits in 2,096. So here 2 plus 0, that's 2 plus 9, that's 11. 11 plus 6 is 17. Is 17 divisible by 3? No, it isn't. For it to be divisible by 6, it must be divisible by both 2 and 3. So in this case, that answer will be no. A theater charging $6 per person for admission to a play cannot take in exactly $2,096 for a night's performance. Okay. All right, so that does conclude this video on section 4.1 dealing with divisibility. Feel free to email me or contact me if you have any questions about any of the problems that are presented in this video or any other problems that are in the homework on my MATLAB for section 4.1.